Okay, so the first part of the guide is converting units, because sometimes with geometry they aren't all the measurements aren't in the same unit, so sometimes we have to be able to change some of them. So you'll always get a table to have the conversion units. Okay, so let's just look at a couple. So if I want to convert inches to centimeters, so sometimes it's just like all metrics. So it might be centimeters to meters, meters to kilometers. That's pretty easy because we know that's multiples of 10. But if it's something like metric to imperial, right, like the old way and the new way, then we need some conversion rates. So if I'm going 8 inches to centimeters, I start, let's just get this. Monday morning, my smartboard is not awake yet. Okay, so we'll start with 8 inches. And first I'm just going to put the unit. So I want to get rid of inches. So I'll put that on the bottom. And then I want to change to centimeters. So I put centimeters on the top. Okay, so that's what I want to convert to. And then I go and look at my conversion table. And here it says here that 1 inch equals 2.54 centimeters. So I'm going to put 1 inch equals 2.54 centimeters. So I fill in those ratio, and then we just multiply. Okay, so 8 is over 1. So we're just going to do 8 times 2.5. And here you'll see that inches cancel with inches, and we'll be left with centimeters. So that works out to be 205.9 inches. Okay, so that's just one conversion. Do my answers here. All right. Let's say we're going 532 centimeters to inches. So we'll start with 532 centimeters. Okay. Now, my table, are we going centimeters? Okay, so I want to get rid of centimeters. So put centimeters on the bottom and inches on the top. Okay, because I want those centimeters to cancel out. Then I go back to my table, and I know that 1 inch equals 2.54 centimeters. So I'll put in that conversion. So this time, when we multiply the top two numbers, right? So 532 times 1, and then 1 times 2.54. So this time we are dividing, right? And that gives us, I think I had that last question wrong. So centimeters cancel with centimeters. Can I just let me go back to that first one, because I had that one incorrect. I was looking at the wrong answer. Okay, so 8, let me grab my calculator. 8 times 2.54 is 20.32. Okay, so sometimes you are dividing, right, because the conversion rate is on the bottom. So just remember, when you're multiplying, it's numerator times numerator divided by denominator times denominator. Okay, some of them won't be a straight conversion. So if I look at meters to inches and I look at my conversion table, I don't have, oh, I do. I have a meters to inches right here. I'm going to show you 2 ways to do this. So let's say we didn't have it. So if we do, we'll use it. So 6 meters, I want to go from meters to inches. So 1 meter, if I look at my conversion table, 1 meter equals 39.37 inches. All right, so if we're multiplying, it's just 6 times 39.37 is 236.22. Okay, so meters cancels with meters, we get inches. You could do that. Let's say we didn't have a conversion for meters to inches. Let's say we still only had centimeters to inches. You could also do it in more than one step. You could go meters to centimeters and then centimeters to inches, right? So you could do it more than one step. So I know 1 meter equals 100 centimeters, and then I have my conversion. 1 inch equals 2.54 centimeters. And I'll end up with the same thing, okay? So you can do it in more than one step. Depends on the conversions that you have, whether you can do it in one step or more than one step. So meters would cancel with meters, centimeters would cancel with centimeters, and then I'll end up with inches, okay? So depending on the conversion chart, if you don't have the direct conversion, you can do it in more than one step. And then you might get some that are, instead of distance or length, you might have volume, right? So ounces, so I want to go 80 ounces. So I want to get rid of ounces and change to liters. So I'll look on my table. I have ounces to milliliters. And I don't have ounces to liters. So I can't go directly from ounces to liters. So I'm going to have to go from ounces to milliliters and then milliliters to liters. Okay, so I don't have liters, but I do have milliliters. Okay, so it says 1 ounce is 28.413 milliliters. So 1 ounce is, let's change this. What was the number? 28.413. 28.41. So that will change me to milliliters, and then I know that milliliters and liters are related. I know there's 1,000 milliliters in a liter, right? So I'll get rid of milliliters, change to liters. There's 1,000 milliliters in 1 liter. So that one I have to do in steps because I don't have that direct conversion. So ounces cancels with ounces, milliliters cancels with milliliters, and then I end up with liters. And that works out to be, let's see. So I'm doing 80 times 28.413 and then divided by 1,000. So any number on the top I'm multiplying, any number on the bottom I'm dividing. So 2.27 liters. Okay. So that's just the first part, is converting units. You will have to sometimes convert units when you're finding perimeter, area, volume, because sometimes all the measurements are not in the same units, okay? All right. So perimeter, the most important thing about perimeter is that you only use the outside lines. So this is very important that we do not include inside lines, okay? I always get students that like to use them, but it's only the outside, okay? Not the inside. So sometimes you might have to determine some measurements. So if I want the outside, I know this is 11. So I'm just going to write my perimeter here. So I'm just going to pick a spot and I'm going to go around. Okay, so I'm going to pick this spot and I'm going to go around. So I know this is 11. This is 4. I don't know this, so that's a side I need to figure out. Okay, so I know that this whole side is 11 and this is 5. So if I take 11 and subtract 5, I'll get 6. So I know these two together are going to add up to 6. Okay, so I'll just put 3 and 3. It doesn't really matter whether they're the same, but they have to add up to 6. So I'll just put 3 and 3, okay, because I know together they're going to be 6. So I've got 11, 4, 3. Then I've got 5, then another 5, then another 5, then 3, and then 4. All right, so I just work my way around. I'll write them all out, and then I'll just add them all up. And then don't forget your units. So we got 11 plus 4. And that's 40. So my perimeter is 40, and the units are centimeters. Okay? Now it wants me to find the area as well. So when you have a shape that you don't really have a formula for, you might need to divide it up into composite shapes. Okay? So it doesn't really matter how I divide this up. So I'm just going to write it down here. So my shape looks something like this. All right, so there's lots of ways I can divide that up. Make this a little bit longer. So maybe I'm going to divide it up into 2 rectangles, right? That seems the most obvious. You could, let's draw it here. Right? I could divide it up this way into 3 rectangles, right? So it doesn't really matter how you divide it up, as long as the total added together gives you the shape. I'm going to do it this way because I have 2 rectangles. So I might call this rectangle 1 and rectangle 2, right? So when I keep my answer, I keep it organized. So area is going to be rectangle 1 plus rectangle 2, right? So I sort of keep my answer organized because a lot of times I'm trying to sort out what you're writing. So the more organized you are, the better for me. So I can figure out where you got all these numbers from. So rectangle 1 has a length of 11 and a width of 4. Okay, so rectangle 1 is 11 by 4. And then rectangle 2 is 5 by 5. This is 5, this is 5. And then we'll just calculate those together. What's that? 69. And don't forget your units. We're doing area, so it's centimeters squared. Okay? If I were doing the other one, I would just do rectangle 1, rectangle 2, rectangle 3, and do the measurements for each. Just make sure that we get the same answer. So if I were doing, oops, I would call this rectangle 1, rectangle 2, rectangle 3, if I were doing it this way. So rectangle 1 would be, so if I divided it like this, then this is 3 by 4, right, that rectangle? So I've got one that's 3 by 4. Rectangle 2 is 5 by 9, right? This is 5, and then this whole side is 5 plus 4, so that's 5 by 9. And then rectangle 3 is the same as rectangle 1. And then we'll just make sure that we get the same answer. So 45 plus 24 is 69. Right, so I get the same answer as if I did the other way. So it doesn't really matter how you divide it up, as long as you kind of be clear what you're doing so that I can check and make sure that you have the right measurements. Okay? All right. Okay, so this one is determine the perimeter and the area. So the perimeter, so I kind of have to divide this into shapes because I have a circular part, right? So my perimeter, so I know this is 12. So it's going to be 12 plus 8 plus 12. And then this part is half the circumference of a circle, okay? So I know it's, if I start here, it's 12 plus 8 plus 12, and then the circumference of a circle, but I only have half a circle, okay? So my circumference of a circle is 2 pi r, or pi times the diameter. So let's use the diameter. Doesn't really matter which one you use, but pi times the diameter is the circumference, and then I have half, right? So I'll divide that by 2. So I know I'm using the diameter because I know the diameter, right? The diameter is 8. So the diameter of the circle is 8, right? So I'm going to use that. So if this is 8, then this is 8, and this is the diameter of the circle. Okay, so my perimeter is 12 plus 8 plus 12 plus pi times 8, and then half of that, right? So that's the diameter. And then we'll calculate that. So I'm just going to use 3.14 for the diameter. If you want to use pi, that's fine. And then you can round at the end, but 3.14 is fine. Plus 12 plus 8. So total is 44.56. And the units are feet. Okay, so don't forget the units. And I was going to say something, and now I forget. Okay, never mind. I lost my train of thought there. Okay, and it also wants me to find the area, right? So I didn't use the outside, right? I just put that in there so I knew the diameter, right? So we'll just do a broken line. So we did 12, 8, 12, and then half the diameter. If I'm doing area, so it's always a good idea to write down the shapes. Like, I know geometry seems very easy, but we make a lot of common errors, right? We still make errors with geometry, even though it looks like it's fairly simple. Okay, so the shapes I have for area is I have a rectangle and half a circle. Right, so it's very easy to just organize your work and look at the shapes starting just in words, right? That way you can kind of get your thoughts organized. And then I'm going to write out my formulas. So a rectangle is length times width, and a circle is pi r squared. And I have half, so I'll divide that by 2. Okay, and then I'm going to put in the measurements. So the more organized you can be, the better. So the measurements of the rectangle are 12 by 8. The radius of the circle is 4, right? Because this is 8, diameter is 8, so the radius is 4. And then we're going to take that total and divide by 2. So 12 times 8 is 96, and then we'll figure out half the circle. So 16 times pi, and then half of that is 25.12. And then we'll add that to the 96. So that is 121.12. And don't forget your units. Okay. So I think it's helpful to organize your work into writing out area, especially area or volume in terms of in words, right? What shapes do we have? What are the formulas for those shapes? And then put in the numbers. Okay, some of them will be sort of negative shapes, meaning that you might have a shape and then part of it's kind of missing, right? Like, it's hard to divide this up into composite shapes, but I could say, well, we're doing area. We're not doing perimeter. So I could say the rectangle is, right, it has this triangle. If I took the area of the whole rectangle, but I cut out this triangle, that would give me the area of the red or the shaded part. So sometimes it's a negative shape, where maybe it's easier to take the whole thing and then cut out a part rather than divide it up into different shapes, because if I divide it into different shapes, it's going to get some weird shapes that I don't really, it's too much work, right? I could probably figure it out, but it's a bit too much work. So I'm going to take the area of the rectangle and then subtract the triangle. So the rectangle is length times width, and then a triangle is base times height divided by 2, making sure that it's a perpendicular height. Okay, so the area of the rectangle is 16 and it's cut off. Let's just make it up. Let's say 10. I guess I cut off that part of the picture. Okay, so the whole rectangle is 16 by 10, and then I'm going to subtract that white triangle. So the base of the triangle is 4. Oops. And then the height, it's given as a perpendicular height, so that's 5, and then divided by 2, right? Base times height divided by 2. So it's 160, 4 times 5 is 20, divided by 2 is 10. So it's 150 centimeters squared. So sometimes we have negative shapes, right? Subtracting some shapes. What else do I have here? Okay, so perimeter and area of this. So perimeter, I'm just going to start maybe here and work my way around. So that's 16. This side is 7. This side is 8. This side is 10. This side is 8. And the reason I know it's 8 is because it has these parallel lines, so I know that the measurements are the same. Okay. This side, well, this side I would have to figure out. So the whole side is 16, and that is 10. So I'll just subtract 10 from 16. So that means this is 6. And then finally, this is 7. Okay, so perimeter, I didn't really need to figure out much. I just had to do that one subtraction, and then we'll just add it all up. So that works out to be 62. All right, so that was fairly straightforward. All right, so the area, let's see what shapes we have. So I think the easiest one is maybe a rectangle and a parallelogram, okay? So a rectangle plus a parallelogram. Okay, so the rectangle, I know the measurements, it's 7 by 16, so that's pretty easy. A parallelogram is like a rectangle but slanted, so it's still base times height, but or length times width, but they call it base times height, and it has to be a perpendicular height. Okay, so see how this is 7? So that means, right, that would be my perpendicular height of the parallelogram. So it's not a slanted height, it's a perpendicular height. So the base of this parallelogram is 10, right? Because it's parallel to that. So this is 10 and this is 7. Okay, so it's just like a rectangle length and width slanted, but it has to be a perpendicular height. What's 7 times 16? Is 112 plus 70 is 102 centimeters squared. Okay, so you just want to divide it up into the most obvious measurements. Okay, so perimeter is pretty straightforward. I'm going to start here. I've got 4. This is given. This is given. And 4 and 5 and 2 and 3.5. Right, so perimeter, this was fairly straightforward. It's all the measurements were there. I just have to add them all up. I didn't have to figure anything out. So that's 26. And then area. Probably the easiest one is divide it into a triangle on the top, and then the bottom is a trapezoid, right? A trapezoid is where you have two parallel lines, one pair of parallel lines, okay? So I'm going to divide it into a triangle plus a trapezoid, okay? So formulas are triangle is base times height divided by 2. And then a trapezoid is so a trapezoid is A plus B is the length of the two parallel lines, okay? And then height is the perpendicular height. So we'll call this A and B. So A and B are the two parallel sides, and then you have to have a perpendicular height, right? Not a slanted height. And then we'll just plug in the numbers. So the base of the triangle, okay, so the base of the triangle, we're going to have to figure out. So I'll just put this here. So triangle, right? So it has to be, the base and the height have to be the perpendicular sides. And I have the height, but I don't have the base, okay? So I would have to use Pythagorean theorem sometimes to find a missing side in a triangle. So we're going to say a squared plus b squared equals c squared. We know this is 5 and this is 4. So the base of the triangle is 3. Okay, so sometimes you have to use that calculation for the triangle. So the area of the triangle, well, let's do the formula. So base times height divided by 2. So the base of the triangle is 3 and the height is 4. Okay, so we figured out this side is 3 and the height is 4. They have to be perpendicular. Okay, the trapezoid has side 1, 4, side 2, it tells me here is 9. Okay, and I probably could have figured this out that way as well, because I have 9, take away 4 and 2, right? So take away 6 is 3. So that's what I got using Pythagorean theorem. I see that now. So the two sides are 4 and 9. And then the height of the triangle is, or the trapezoid is 2. So 3 times 4 is 12, divided by 2 is 6. 9 plus 4 is 13. 2's cancel, so that is 13. And so 19 centimeters squared. Okay. This is actually good practice. We could have figured that out from the diagram, but it's good practice to use Pythagorean theorem because sometimes you'll have to use that in some of these shapes. Okay, so that's just perimeter and area and composite areas. The other part of the guide is volume and surface area.